Hi friends, welcome back to my channel. So today let us begin with a new concept which is related to engineering. So M3 subject named as transfer calculus, Fourier series and numerical techniques. So in this let us begin with the first module, that is Laplace transform. So let us directly get into the concept. What does Laplace transform? So definition of Laplace transform is, so if f of t is a function for all t greater than or equal to 0, and its Laplace transform is defined as, so L of f of t is equal to integration of 0 to infinity e raised to minus st f of t dt. So you consider if f of t is the function and where t value is greater than 0, equal to or greater than 0, so then the Laplace transform of this f of t can be written as L of f of t. That means Laplace transform of f of t is equal to, the formula is integration of 0 to infinity e raised to minus st into f of t dt. So where this S is Laplace parameter. Okay, let us consider an example. So uh, let us take, if f of t is equal to 1, so then what is L of f of t? So we know that f of t is 1. They have given us f of t function. So let us substitute this in our formula. So formula is L of f of t is equal to integration 0 to infinity e raised to minus st f of t dt. So this is our function, sorry, this is our formula. So the thing we need to do here is substitute 1 wherever you find f of t. Okay, so L of 1, why 1? Because it is f of t, so we are finding L of 1, L of f function. Okay, so 0 to infinity as it is. So e raised to minus st, let me write it as it is. So f of t is nothing but 1 into dt. So 1 into e raised to minus st is same as it is. So 1 into anything is same the number. So 0 to infinity, so this becomes e raised to minus st dt. Okay, so integration of e to the power, so integration of e to the power x is equal to 1 by x. Okay, so this is the integration value into e to the power x as it is, sorry, e to the power ax. So then 1 by a e to the power ax is the answer, integration value. Okay, so I'll apply the same formula method to this particular e raised to minus st. Okay, so it becomes minus, because s is minus here, so we are writing 1 by a, 1 by here. In term of s we are having a in our general formula, so it is a, means it is minus s, we should write here minus s, so 1 divided by minus s. Okay, so e raised to minus ax as it is, so here e to the power minus st as it is. So we need to apply this limit again. So it is the rule in our integration, we need to apply this limit as it is. So now minus 1 by s, it is a constant because the only variable term is t, so s becomes constant, so I'm writing this one minus 1 by s as out. So now in integration we need to apply limits. So here upper limit minus lower limit. Okay, so e to the power minus s, t means infinity, we should write infinity. Okay, minus upper limit minus lower limit. Lower limit is e to the power minus s into 0. Okay, fine. Now 1 by s as it is. So e to the power minus s into infinity. S into infinity is again infinity. So e raised to infinity or anything raised to infinity is always 0 minus e to the power minus s into 0. S into 0 is 0. So anything raised to 0 is 1. Okay, this is the general equations. Okay, so it becomes 1. So now 0 minus 1 is minus 1. So 1 divided by s into minus 1. Okay, minus into minus it becomes plus. So it becomes 1 by s. So the simplified answer, the L of f of t of 1 is 1 by s. Okay, so let me take another example. Consider f of t is equal to 2. Find L of f of t. Okay, should find. So let us consider the same formula. L of f of t is equal to integration 0 to infinity e to the power minus st f of t dt, right? So you should substitute 2 everywhere where you find f of t, integration 0 to infinity as it is e to the power st. So f of t means 2 into dt, right? Okay, now 2 is a constant term, it will not vary. So let us write this 2 outside. Okay, 2 outside. So now the remaining is 0 into infinity e to the power minus st dt. So as we done in the previous problem, it is same as like that. So answer integration of e raised to minus st, we just apply integration. So 2 into it becomes minus 1 by s, we are going to write down. Okay, so integration 0 to infinity e raised to minus s, sorry, we need to apply integration, right? So 1 by s into e to the power minus st 0 to infinity. Okay, so it becomes minus 2 by s. I'm just simplifying, I'm writing it in a neat manner. So apply limits e to the power minus s into infinity minus e to the power minus s into 0. Okay, so minus 2 divided by s into this becomes e to the power infinity is 0 minus e to power 0 is 1. So again it becomes minus 2 by s into minus 1. So minus into minus plus 2 into 1 is 2 by s. Okay, so from these previous two problems we are going to generalize a formula that, so f of t, in previous I have considered 1 and in one more problem 2. So 1 and 2 are constant values. So let me take constant value as a. Okay, so now you have to find L of f of t. So we have to find the Laplace transform of a. A is nothing but a constant value. Here 1 was also constant and 2 was also constant. So now we have to find, I'm going to generalize the formula for a constant Laplace transform value. Okay, 0 to infinity e to the power minus st f of t dt. So let me directly substitute the value. 0 to infinity as it is, e to the power minus st as it is. So f of t means it is a. Okay, a into dt, right? So a is a constant value, let me take it out. I have written it out. So now we have to integrate this value with respect to t. A you have already taken out, so integrate this with respect to t. So integration of e raised to minus st is 1 divided by minus s e raised to minus st, apply the limits, right? So a into we just simplify this, a divided by my s. Okay, now applying the limits. e to the power minus s into infinity, e to the power minus s into 0. So minus a by s, so it becomes e to the power minus infinity is 0, minus e to the power minus s into 0 is 1, anything raised to 0 is 1, so it becomes e to the power minus a by s into minus 1, with minus into minus plus s, a into 1 is a, so it is a by s. So the general formula, you see, if you get any constant value, consider if you have in place of a, if you get 12, you just need to write the Laplace transform value as just 12 by s directly you can just write this. So it is a generalized formula. This is the very first concept in our Laplace transform. So in next session I'm going to tell you about properties of Laplace transform and one more basic generalized formula in Laplace transform. So to reach out to those videos, follow and subscribe to my channel. Thank you.